So in our residual plot, we still have the same thing. There's going to be 100 minutes. And then, I don't know if you remember, but there's a middle line that goes across. This is the x-axis kind of thing when we do our residuals. And when you do your residuals, you actually have to find the values for these residuals in your calculator. And we did this a long time ago, so I'll refresh your memory again. So you go into your calculator, and when you go into your stats and edit, you arrow up to L3 and hit enter. And that's when you go vars, yvars, function, enter, because you have that regression line in y1. You put a parentheses, and then you do plug in all of my x values from list number 1. And what this is telling my calculator to do is, hey, I have a prediction line. Let's find out what I was supposed to see as the y value based on my data. And you hit enter. And all of these values in list 3 are the predicted tips that you were supposed to leave based on the time that you were staying there. And the residuals are always your observed values in list 2 minus your expected values in list 3. So now I go over to list number 4, and I arrow up, hit enter, and I type in L2, minus L3. And what this is going to give me is all of my residuals. So in list number 4, I have all of my residuals. So now I have all my residuals, and I just want to graph that. So when you graph your residuals, you graph L1 versus L4. So I go into my stat plot this time, and I'll shut off my other graph. And I'm going to arrow down, and instead of doing L2, I go second, number 4. And this is now my residuals. And I go zoom 9 again. And the line that you see across the middle, that's your x-axis. And so then you just plot that. And I don't really have, have a way to show this screen and the other one, so I'm just going to rough estimate what it looks like on the other one. These are the values -1, -2, -3, +1, +2, +3 on the screen to the left on the y-axis. So let's go back and I'll graph this one in a different color maybe here. So my residual plot, again remembering that this is -1, -2, -3, +1, +2, +3. I guess I didn't need that bottom bar, but I just wanted to show the scale. So my residual plot looks something like this. Okay, and what you're looking for in your residual plot is really that there's not a pattern going on. So this is my residual plot. Questions about the residual plot? This is one that if we saw the residuals and we saw a pattern, we're like, whoa, something's really wrong here. They should all be centered around the x-axis, no extremes one way or the other. They should even out as many above and as below. And that's what you're looking for to see, if, again, if it's a linear model is a good fit. And then our last one is a normal probability plot. And it looks something like this. Off to the side here, this will be the z-scores. And down below are the residuals. And for the z-score, 0 is in the middle. You'll see what it looks like as soon as we get it up here on the screen. And then for the residuals, 0, -10, -20, 10, and 20. You can actually check this out on your calculator when you go do the zoom 9 kind of thing. And the nice thing is that your calculator actually already has this built into it. You don't actually have to figure out how to do it. Your calculator will do it for you. So So z-scores on the y-axis, and then residuals along the x. So in your calculator, here's how you do it. By the way, all these things are in your book. If you look in the back of your book, they'll tell you if you don't remember how to do these. There's a page in the way back that tells you how to do all these different kinds of plots. So I go second y equals, and when I get in there, it's the last plot. And then you just go zoom 9. And what you're looking for is a linear model. As you can see, it's a linear model. I'll graph this on our screen in just a second. So this is exactly what you're looking for. You want to see a tight banding, something that has half of it above, half below, crosses roughly in the middle of the x-axis. That's what you're looking for in your normal probability plot. Okay? So when I graph these, it looks something like this. And there's the x-axis that was going across. Notice how the dots are roughly crossing in the middle. And this was our normal probability plot. In part B, it says, what's the equation of the least squares regression line for predicting the amount of the tip from the length of the stay? Define the variables, and here's the mini tab. So this is what we did yesterday in our lesson. So first of all, when we're talking about a regression line, we always have y hat, because that's our prediction. And then it's equal to 4.535. That number is coming from where you see the constant. That's the 435. And then it's plus 0.03013x, and that value is coming from the time. So these are both the coefficients. One's for the constant, your y-intercept, and one's for the time, and that's the slope. This is the way the Minitab produces it, so why don't they just say slope and y-intercept? I don't really know. That's just the way the computer does it. And then, so what you should do is you should define the things off to the side, of course, because that's what they said. So we know that y hat is the predicted tip amount in dollars. And the x is the length of stay in minutes. So that's what they mean by define the variables. What is your y hat? What is your x? In part C, the first part, let's talk about the slope. So the slope, which was that 0.0303? 13? Like this?
Yeah.
All right. So this means that for each additional minute spent in the Asian buffet, on average, the tip increased 3 cents. The y-intercept, which was 4.535, means that just walking in the buffet guarantees a $4.54 tip I would say this is not necessarily likely, because just because you walk in doesn't mean you're going to leave a tip, especially if you haven't spent any time there, bless you. However, that's what the y-intercept does mean. So now we carry out the test.